Hello students, welcome back. I am Rinkesh sir and today our topic is Newton's universal law of gravitation. Okay, so let's start. Every particle in the universe attracts toward it every other particle with a force directly proportional to the product of their masses and inversely proportional to the distance between them. Okay, so see, if there are two masses m1 or two object particles having mass m1 and m2, let the distance between them be r. So now see, according to the Newton's universal law, it says that the force is directly proportional to the product of their masses. Okay, so it's directly proportional to m1 and m2 and inversely proportional to the distance between them. So F is inversely proportional to distance between them. Okay, so F is equal to F is proportional to M1 M2 by R square. Now, when we remove this proportionality sign, then we will get a constant that is called gravitational constant. G m1 m2 by r square, where G is gravitational constant. Its value is 6.67 into 10 raised to minus 11. Okay, this value was determined experimentally by Cavendish. Okay, so now see, this we have converted the statement of Newton's universal law into mathematical form, that is gravitational force acting between any two object or any two particle with masses m1 and m2 is g m1 m2 by r square. Okay, so remember that in this universe every particle attract other particles or every other particle with this force. Gravitational force is a long range force. Okay, gravitational force is a long range force. So it doesn't matter however far it will be. Okay, gravitational force will act. It's just that when the distance is very very large, the value of gravitational force will be very very less. So it will be negligible. Okay, so gravitational force, it's a long range force. Again, gravitational force is the weakest force among the four fundamental force. Also, gravitational force is the weakest force among all four fundamental forces. Okay, now G, that is the gravitational constant. If I want to find out unit of G, okay, unit of G, then I can see here that is F equal to G m1 m2 by r square. So G will be equal to F r square upon m1 m2. So the unit of G, unit of force, Newton. Unit of r, that is distance, meter square. Okay, m1 m2 kg square. So unit of G is Newton meter square per kg square. The dimensional formula for G. Now the dimensional formula for G. Dimensional formula for Newton, that is force m1 l1 t minus 2. For meter square l2. And for kg square is m2. So we have 1 minus 2, that is m minus 1. L 1 plus 2 3. T minus 2. Clear? Now let's see it in vector form. Okay, or else first just note down this topic, then we will see it in vector form. Here I can write it down Newton meter square per kg square. Okay, now let's see in vector form. Now let this be x-axis, y-axis, and z-axis. Now let's take two particles having mass m1 and m2. Let the position vector be r1 and r2. Now, see what does the statement says? Attract towards every other particle. So the force acting on m1 will be in this direction, means force acting on 1 due to 2, and force acting on m2 will be in this direction, force acting on 2 due to 1. Clear? Okay, let this distance be r1 2. Clear? Or let's say it will be, if I take this direction, okay, then that will be r1 2. Okay, now see here. So now the force will be attractive. So the force acting on 1 due to 2, that will be directly proportional to m1 m2 and inversely proportional to 1 by r square, inversely proportional to square of distance between them. So this will be equal to g m1 m2 upon r12 square. The direction will be r12. Okay, clear? So this is the force acting on 1 due to 2. Now the force acting on 2 due to 1. Now see here r12. Before that, r12 is a unit vector. So that will be equal to vector r12 upon r12. Here this is the vector r12 upon modulus of r12, means the magnitude of r12. Similarly, if I want to find out force acting on 2 due to 1, then that will be equal to g m1 m2 upon r21 square unit vector r21. Now see here, R21 means the same distance between M1 and M2. If I take magnitude, then R21 will be equal to R12. So that will be equal to G M1 M2 upon R12 square. But now the direction of R21 is opposite to R12. So I can write a minus R12. So I can say that F21, that will be equal to minus F12. Okay, so both the force acting on 1 due to 2 is equal to the force acting on 2 due to 1. Okay, but the direction of both the forces are opposite. Here, this is similar to Newton's third law of motion. Right? Both the forces are same, but their direction is different. So I can say that F21 and F12 means force acting on 2 due to 1 and 1 due to 2 are same. Means magnitude of F12 and F21 are same, but their directions is opposite. I'm not a different item, opposite. Here, so this was about Newton's universal law of motion. So note down this vector form. Okay, students, so that's it for today. Thank you.